and welcome everybody to the Daily Space Weather. Today we'll be talking about the continuation of a Proton event, Simulquakes, Coronal mass ejection, yeah, another one, as well as our mission. Let's do it. Here's the sun in 94 angstroms over the past 24 hours. Looks like we saw a C-class flare quite recently. It looks like it came out of that active region in the north. Quite unexpected. It's not even a sunspot. And right there looks like the onset of that C-class flare to me. I'm not going to do a detailed X-ray analysis of it because it's not necessary. The 10.7 centimeter radial flux now at 109 solar flux units. So there you can see the 1 year graph as reported by Solon.info. And if this graph had it drawn in, it would be way up here. Whoosh. Way up there. So abruptly coming out of a lack of solar activity and seeing some solar activity. We've got some great HelioViewer movies today. We're going to save those for the end of the video and talk about the mission. What's the mission? Well, head to smAshomash.com/forum/mission if you want to share it or read it over for yourself. But the mission is to assist, study, and report on the ongoing formation of a unified theory of physics to raise the awareness of the general public of the relationship between space weather and Earth effects. Part of the reason why we do the videos. To connect and consult with media organizations to multiply our reach. Same deal. To demonstrate cutting-edge proof-of-concept solutions to problems, to publish scientific papers in a multidisciplinary manner, because multidisciplinary science is the way of the future. Be well-rounded. 6, to assist mankind by advancing the study of predictive phenomenon in order to optimize value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is, no matter how ridiculous and silly the adversity is. We'd like to help folks adapt to it. And lastly, to not be ossified in our beliefs and to treat those who are with love, respect, and inclusion to the scientific discussion. So adversity such as that makes you want to put on your safety glasses and blow it off the screen. Thanks to our patrons for helping to support our mission. Patreon.com/smAshomash. If you'd like to become a patron, please consider doing so. You'll receive all kinds of perks and early updates before anybody else. Thanks to our patrons, the real source of funding for the content. Today's Smash Lights will be postponed. We will possibly make one in the afternoon. I would also invite everybody to head to smAshomash.com. You can find all of our social media links there. We've recently gotten to over 100 followers on Twitter. Also check out the Smash Forum and the smAsho store, all linkable at smAshomash.com. And any orders at the stores, for instance the smAsho store, will receive a 10% discount through Christmas on all orders received by entering the promo code smAsho on checkout. And so we invite you to Mansa, Make America Not Suck Again, with these nonpartisan t-shirts. And thanks to everybody who's been picking up merch. It is a great benefit to our causes. Now today we're going to talk about cosmology briefly. First, I would remind everybody to please take a moment to press like and subscribe on YouTube. youtube.com/smAshomash. Press the notification bell if you haven't seen our smAshomash.org Presents the Sun videos. They're quite epic. And we covered the recent M-class solar flare and accompanying coronal mass ejection in great detail on Sunday. So check all of that out. youtube.com/smAshomash. And let's get on with the cosmology segment. By the way, we also are streaming live to Twitch. It's twitch.tv/smAshomash. Thanks to all of our subscribers over there. and the kind comments. We even appreciate the unkind comments. Don't worry, you won't offend me. Today's cosmology segment will be brief. We're not going to throw any dice. We're going to talk about V1787 Orion, rather. And it is a certain type of star known as a, I forget. It's known as a, come on, memory. It's got a companion. It's a special type of star that's located inside of an envelope of gas and dust known as a Herbig AE/BE star. So you've got spectral lines and Balmer series lines in these sorts of systems. This one noted by some Indian astronomers. You can read a paper about it, and you can link to that at phys.org's Astronomy and Space section. A companion star noted in the constellation Orion, located at about 1,260 light years. And there's their imagery of that. And let's move on to look at more data. As we saw a coronal mass ejection strike, and then a ramp down. So here's the real-time solar wind. Whoosh. And you can see right here, the solar wind density made it all the way up to about 30 protons per cubic centimeter, I thought I saw there. At least 25. And then dropped right back off. We saw the solar wind speed make it up to about 560 kilometers a second for a brief period, and then ramp back down. So that was part of the coronal mass ejecta associated with that M-class flare that we saw on Sunday. KP index is back down to 0. And check out the geospace. It's quite volatile out there. So first we're looking at the velocity here. And you can see significant changes happening there in the velocity. Low velocity shown in red, high velocity shown in blue. And here you'll see this ramp way down. There's more of a median velocity. And we're going to show you the density as well as the pressure also. We just saw a major downtick in the pressure as well as the density. So here you can see this low density situation here. Low density shown in white, high density shown in dark blue. A likely indication that the proton event is going to ramp down, but we'll be keeping an eye on that. When I say ion, oh well, the pun is intentional. There's that low density scenario happening. And here you can see the pressure was quite high, and then it's going to just fall off a cliff. We'll let that play through again as it refreshed. Ah, yes, the dangers of streaming live. We appreciate the live format, by the way. We do this not only for compactness, but also because it creates a tension that would otherwise not be there. A la Rush Limbaugh, who agrees. And here you can see that ongoing proton event. And we haven't seen this happen for a couple of years. If I had to guess, I would say this is going to ramp back down based on the information I just showed you. There's that C-class X-ray flare. Looks like 2 C-class X-ray flares, actually. And you can still see that M-class flare that happened on Sunday. Again, check our playlists out on YouTube if you haven't. youtube.com/smAsho/playlists. And next I've brought up a star chart for you here. I like to face mine to the south and include the ecliptic. Welcome to December. Now, I just wanted to show you a little diagram here. So here's a diagram of Lagrange point 4 and 1 and Lagrange point 5, where stereo A is located. Stereo B is located out here, by the way. This is where stereo B is. And stereo B is lacking instruments as it experienced a hardware anomaly back in September 2014. So we don't get very much data from that. Magnetometer still does appear to work. And I just wanted to show you Venus showing up. So a great indication of where stereo A is located. You can see Venus there on the right of your screen. Just moving into view, so we should have a great view of that. And you can see the coronal mass ejection that actually just occurred while we did show prep, maybe the hour or two leading up to it. So clearly you can see where stereo A must be located right to there. So that's actually Lagrange point 5, a great example of where it shows up on the map. Hopefully that gives all you new viewers a little better idea of where things are located. Here's where things will be in a week on December 8th. The magnetometers, we're seeing high highs and, well, we're seeing average highs and high lows here. And the south solar polar field is looking quite strong. And we'll show you a diagram of the current sheet, which gives us insights into that in essentially real time. It's the top view ecliptic plane field plot. You can see the Earth is currently in the south and the north pole current sheet here shown in green. And you can see the Earth's potential field force lines there. The Earth's potential field force line in orange. And the fact that we see South Pole charged current sheet here arriving shortly, an indication that the South Solar Polar Field is quite strong right now. And here's a view of the coronal hole field plot, and you can see a lot of South Pole magnetism there creeping up toward the equator. It looks like another coronal hole is rotating in. And this does give us a better view than just looking at the SDO's wavelengths here, as this is based on a lot of magnetometers, both on Earth and on stereo A and B. Here's a line of sight field plot, which also shows you the solar magnetometer data. And the B field here, which is the one on which we live, is shown in blue. The B field is the field that goes through a magnet. It also shows you the Z fields, which are the polar fields shown in green and red, north and south poles respectively. Next, the coronal magnetic field plot. And we see quite a lot of closed potential field surface source lines there in pink. And let's talk electrons, as there's a lot of stuff going on in the ionosphere. Here's part of it. We don't see any charging hazards. We are expecting an uptick here, a big-time uptick, I would say, in electron flux. There's the one-year chart. And I think this is going to be a little bit higher than this. I'll say it's going to be more like in this area, following that coronal mass ejection. Now, coronal hole wind streams tend to lead to longer and more sustained electron storms, but I would say, probably a little bit higher levels of electron flux than this forecast would predict. And there's the 3-day chart. Very level electron flux over the past 24 hours. And here's a visualization of the whole air column. This will give you a good idea of where GPS errors are located, and there are significant ones over places like the Central Pacific. Let me rock that back and forth here. And some pretty significant electron flux anomalies here over North America once again. Would have had pretty significant GPS errors yesterday over most of the US and Canada, despite it being autumn. As winter approaches, by the way, we will be doing a live stream at the time of the solstice. And let's talk about the ionosphere. Yesterday we explained this, and so you've got the D layer and the E layer and the F layer. These are at increasingly high altitudes. The GOES 16 is measuring things up here at the F layer, or it endeavors to. And let's see what's going on at the F layer. By the way, this data is courtesy of Australian Government Bureau of Meteorology. By the way, the earthquake warning has not subsided. We've got another, I'll say another solid 24 hours of major earthquake warnings. We saw a pretty anomalous pair of simulquakes yesterday, hence the word Simulquakes in the title. Maybe that's a new term. Maybe I should copyright the term and trademark it. Here's the latest image on the ionosphere. That one's at 9:45. Not looking all that anomalous at that moment. Next, we're going to look at just the D layer. So now we're down here. And what this is looking at is the absorption of radio signal. So when we have a lot of photons and indeed protons raining down, we see absorption of radio signals, which causes radio blackouts. And perhaps at the end of this, we'll see this subside a bit. That would be my guess. We'll just let that play through. You can actually see that C-class flare there happened when the sun was over the Indian Ocean. And you can expect to see that subside a little bit throughout the day. You can view this yourself. It's called the D region absorption predictions. Next, looking at the Aurora forecasts. And we'll probably see a ramp up and then a ramp down in the Aurora as well. There you can see the ramp up. And part of the reason why we show all the data every day, folks, is because we want our viewers to be able to do my job when I retire from doing the daily space weather videos, which, by the way, is part of the plan. There you can see the ramp down. Next, looking at volcanoes over the past 24. Suwanosejima is erupting still, flight level 050 there. Dacono is erupting as it explodes, flight level 070, that's a 7,000 foot ash plume. Popocatépetl still exploding, which is on my bucket list to visit. It's producing a 20,000 foot ash plume. Fuego exploding, 16,000 foot ash plume. Telica, now on the list, exploding, flight level 050 there. It's producing a 5,000 foot ash plume. Sangay also exploding. I believe that's an uptick at Sangay, correct me if I'm wrong. It's a 20,000 foot ash plume above that. And Sabancaya, intermittent puff emissions are a reminder to not attempt to pole vault the caldera. So the largest earthquake of the past 24 was this 6.4, which is actually west of the Kamchatka Peninsula. There's the location of that one. But the interesting thing about that is not just that. It's that another quake happened within 30 seconds, way across the world. Yeah, all the way down here in South America. Those quakes happened practically simultaneously. Let's scroll up the list and see what else is going on. Looks like a small swarm of quakes in California. I thought I was going to say Salinas, California. How about a 4.1 in Afghanistan at 172 kilometers depth? So several deep quakes kicking off here, especially that pair of 6+ magnitudes. Also a 4.5 on the Kamchatka Peninsula at 163 kilometers depth. So there you go. A 6.4 magnitude quake at 587 kilometers depth struck yesterday at 22:54 Universal Time, west of the Kamchatka Peninsula. And at 22:54 and 59 seconds, only 25 seconds later, a 6.3 struck the Chile-Argentina border region, also at depth, 147.8 kilometers. And by the way, if this 6.4 would have happened at the surface, that would have been nearly an 8 magnitude quake, as it was at 587 kilometers depth. The Chilean-Argentinian one was 147 kilometers depth. There's another deep quake at the same location, a 4.3 magnitude at 176 kilometers depth. The planet is reminding you to have an earthquake plan, folks. If you're in an earthquake-prone zone, such as these areas, know what may happen in the event of a massive disaster. Know which building facades may collapse. Know which stores may be looted if the power goes out, and stay away from those locations. Let me just check the life of the stream here and encourage all of our viewers to leave a comment. Next, looking at windy.com's pressure maps. We see a massive high pressure system here in the northern Atlantic. That is indeed an anticyclone. You can see the clockwise rotation of that system. That is a major meteorological forcing input. We're just going to advance this here into the GFS forecast. There's where we expect things to be at 12 noon. Tomorrow, according to the GFS forecast, the U.S. almost entirely dominated by high pressure. A double high pressure ridge there over the northern Rockies. Next, we're at nullschool.net to see some extreme jet stream flows here in the 250 hectopascal winds. Yowzers. Some major cold air dipping way down into places like Alabama and causing measurable snow so early in the sort of meteorological winter, you could say. There's where lightning strikes are happening. I like to use lightningmaps.org. And you can see most of the lightning here around the U.S. is in the Atlantic. U.S. Doppler radar showing us a bunch of snow here. And it looks like it's stagnating a bit. Not really moving at all. We'll show you why on the next slides. Here's what's going on in the cloud layer. And here's water vapor. You can see that there is a bunch of dry mass of air surrounding this low pressure. And until that gets a move on, those systems are going to take their time. So again, there's the cloud layer. Here's water vapor. And we'll actually zoom in on Ohio. And for all of you viewers in the Midwest, that should give you a better indication of how this is going to move. And it's going to move slowly, as is super obvious from this animation. Now we've got bonus features, mainly our HelioViewer movies, but we're also going to show you the intensitygram and the colorized magnetogram of the local yellow dwarf, otherwise known as the sun. Also, I'm going to vanish. Remind you to visit our websites, smashamash.com. Again, don't forget to enter the promo code smAsho on all orders to save 10% through Christmas. Just enter the code smAsho at checkout and you'll save 10%. We'll be sending out a bunch of smAsho merchandise as Christmas presents. Here's the colorized magnetogram. Sunspot 27, 85, and 86 are still significant. There is still a chance for X-class flares, as well as a higher chance for M-class flares. There's a huge spread here in between Sunspot 2786 and its trailing umbrae of opposite polarity. There's the newest sunspot to rise. Again, this area up north is not a sunspot, but it did appear to produce a flare. Correct me if I'm wrong on that. It's located in that area. Here are the umbrae, 2785 and 2786. The trailing umbrae look like they may have degraded a little bit, but there's a lot of space in between those, and there's still significant plasma out there to be ejected. And there's the latest sunspot. I think that's 2788. Again, correct me if I'm wrong. And let's check out our HelioViewer movies. And here you can see the coronal mass ejection listed in the title. Probably associated with that C-class flare. Frankly, I didn't even check it out. It's not Earth-facing. At least not the part that's fully ejected at this point. Here's a zoom in. There's a little closer view of the same scenario, featuring the 304 angstroms view as well as the LASCO C2. And indeed, that's most assuredly the C-class solar flare we saw there coming out of that active region in the north. Here's a close-up of that, along with the Earth scale there above sunspot 2786. Kablooey. I'll let that play through a second time. And here it is in 171 angstroms. And we'll also show you a close-up of the southern hemisphere to close things out. Anyway, thanks for tuning in, folks. Remember, stare at the sun, don't drink, and if you do, don't drive. I don't care if you drink. Just don't drive. Or if you do drive, be a pro, as it's probably the most statistically dangerous thing that you do on a daily basis. Here's the southern hemisphere. And welcome to the Neo-Renaissance. And since it will never be now again, may that solar wind be at your back.